the integral is kind of embedded in it. So if the series has a sum where S of n is the nth partial sum of the series, so we can account for that. You can approximate the sum by using the nth partial sum, and the error will be whatever the first truncated value would be. So the next term in the partial series. All right. So what that's telling us is, let's say you have something like this, right? But instead of going from 1 to infinity, I'd go from 1 to 4. So I'm looking for S sub 4. That would be the sum of values from 1 to 4. I won't write it as a sum because we actually have to figure them out individually. Right, so plug into 1. You're looking at, the top is just addressing the sign, positive or negative. So once you know where you're starting, you know you're alternating from there, you really don't have to worry about it anymore. So on the bottom, I know it's going to be 1 factorial. If I plug in a 1 on top, I'm going to get a 0 exponent, which is going to make the negative 1 become positive. So this is going to become positive 1. For the second term in the series, it would be, if I plug in a 2, I'm going to get an exponent of 1. So it's going to give me a negative 1 over 2 factorial. So really the idea of plugging away is not necessary anymore because I know it's going to alternate back to positive over 3 factorial. And then back to negative over 4 factorial. All right, so what I want is the sum of these values. Now, what they're telling us is that the error will be defined by the first truncated value. So if I were to go, they asked me for 4, if I were to go to a 5th one, this would represent the error. So this is my approximation. The 1 over 5 factorial would represent the amount of error. All right. So I could figure this out, but I could also, just type it in, give the brain a rest. Although it's really not that bad. I'll just kind of split the difference here. It should be minus. I'll just do it again. Plus 1/6 minus 1 over what, 24? So you get that, looks like. Math bracket if you want. 5/8. With an error of 1 over 120. 5 factorial, I think is 120. All right. So what that's telling us is that we're looking at 5/8 with an approximate error of 120. So whatever the real answer is, it's going to be within 120, 1/120th of the 5/8. All right. So if I want an interval that represents my correct answer, I would say S would be equal to the 5/8 plus or minus 1 over 1/20th, right? Because it could be within 1/120th of 5/8. It could be on the low side or on the high side, right? So that's what this method allows. So this is the approximation based on the terms. This is how much error that we can expect. That's still going to be in the interval. Plus or minus gives us a range. actually writing it in interval notation, which you could, but this is the shorthand for that. So, if you wanted to, you could say, 5/8 minus 1 over 120, comma 5/8 plus 1 over 120. And then bracket it up. That's the max error. So technically the error could be exactly 1 over 120. So we do it this way, but it's understood that this means it's so not specifically 2 endpoints, but also everything in between. All right, so the second example is pretty much the same thing, so I'll put a star on that. Same concept. I mean, it's a slightly different question, but same concept.